So, this is me. I'm Ben Nuttall from the Raspberry Pi Foundation. I'm an education developer advocate. I do software and project development, create learning resources for use in school or kind of hobbyist stuff. And we do some teacher training as well. We do called PyCademy. I also do a lot of outreach, go to a lot of PyCon conferences and things. We're based in Cambridge. That's me on Twitter, Ben_Nuttall. You may have seen me here last year or at EuroPython the previous 2 years, or PyCon Ireland or Python San Sebastian, or Euro SciPy last year as well. So this is Raspberry Pi hardware where we're at the moment. This is Raspberry Pi 2, a 900 megahertz quad-core ARM7 with a gig of RAM. This is the new one in case you're unfamiliar. The previous model, Raspberry Pi 1, the previous model looks exactly like this. There was a revision before that. It's the same. We maintain the same form factor as the B+, which was the last revision of the Raspberry Pi 1. Kept it at the same price, $35, about £26. The B+ is now $25, and the A+, which is a kind of cut-down version with no Ethernet and a single USB, and that's now $20. We're all about education. We started as an educational charity. They founded it as a foundation to aid computing education, and Raspberry Pi kind of was brought forward as something which would lead to the answer, rather than it being a hardware company that tried to get into the education market. It's been on sale. Raspberry Pi has been on sale since early 2012, and it's been available, always been available to everyone worldwide. It's not something which is the lower price point for education or the third world. It's the same price for everyone. So we get a lot of hobbyists buying them and a lot of people in industry using them in machine testing and factory testing and things. So we do sell to lots of different people for different purposes all over the world. And we sold 6.5 million to date. It was about 1 million in the first year, and it's kind of really ramped up since the Pi 2. We create free learning resources and do teacher training. We're going to be taking our teacher training to the US next year, and we're doing it around the UK at the moment. I've got to start with a couple of stories about kind of things that are leading to what I'm going to be talking about. So Ben Crostons, who's sitting here, he brewed the beer for PyCon UK this year and last year as well, if you were here. And he brewed it with a Raspberry Pi, and he uses Python. And Ben kind of ended up writing some code, which meant that he could talk to the GPIO pins in Python to do some of this beer brewing process. And that's one of those things, a project that became a library, became a module. And this module that came out of this project is what we use in all our educational resources. And it came from beer. Another story, Dave Jones is a friend of mine up in Manchester. His wife's a paleontologist, and she wanted to use the university's microscope for some microscopy, and it's a real faff the way that they set up the whole process, so that you had to, it basically uploaded all your things onto this server, and you had to go and ask for permission, and then you might get your pictures back within a few weeks or something like that. It was ridiculous. And he just said, well, just stick a Raspberry Pi and a camera on the top and take the output straight from the lens and just save that. And he built a little thing in Python and built a little web app that categorized things. And again, this became the way that you access the camera module in Python. And I actually mentioned this to him recently. I said, oh, when I do these talks, I talk about the project that you started for your wife. And he said, oh, was that why I started? Oh, I ought to finish that. I forgot about that. Brilliant library. Check it out, pycamera.readthedocs.org, full of everything you could possibly want to do with a camera. And it's really, really nice, really good Python module. Raspbian is our Linux distribution that we use. It's a foundation-issued Debian-based distribution. It's currently based on Debian Wheezy, and we have a Jessie image in the works that's coming out soon. The image that you get from raspberrypi.org you can download that and put it on an SD card, a micro SD card, and it will run on a Pi 1 and a Pi 2 the same. So we kind of backwards compatibility with Pi 1. There's a bunch of software comes pre-installed that means you can use it for all the stuff we expect people to use it for. So a lot of educational packages, software. So we have Python 3, and for those legacy users, we also support Python 2. Ruby's on there. A great programming environment called Sonic Pi is based on Ruby. That's really good for creating music and learning computing through creating music on Raspberry Pi. And Java and Mathematica and other stuff as well. But there's also kind of some of the useful libraries. So the Ben's GPIO library is on there, and the Pi camera library. And so when we're on a just Jessie image, we'll be shipping with pip and the Python dev tools as well. There are other images available, Ubuntu Mate and Snappy Core and Arch Linux and stuff like that. But we kind of, for educational uses and general purpose use, Raspbian kind of has everything you need, and it's a good place to start. So when I'm talking about GPIO, this is what I mean. So these pins along here, they kind of stick out, and they are this is what we call the GPIO bank, the general purpose input-output pins. You can connect things to those pins that control things in the real world, or listen to things in the real world. And this little keyring thing that's sticking up, that's laying on top of them, is just, like, it may as well be a piece of paper. That's just a guide to show you which pin is which. We call them the whole GPIO bank, but strictly speaking, they're not all for general purpose. So some of them supply you a particular voltage. So you've got 3 volts and 5 volts pins. You have a ground pin, which is kind of 0 volts, which is a way that you complete a circuit. You bring it back to ground. And then you have these ones that are labeled GP2, GP3, GP4. Those are your general purpose pins that you can program you can program yourself. So you can turn one of those pins on or turn it off, or if it's an input, you can listen to something to see when it changes and that kind of thing. If we're looking at analog, there's no native analog on Raspberry Pi. So if you're used to Arduino and things, you can actually have analog sensors on there. There's nothing, as I say, native. None of those pins are analog, but there's options. You can use an ADC, an analog digital converter. There's various Arduino-like boards that will sit on top of a Pi and do the Arduino bit, but then you can program it in Python and tell the Arduino bit what to do. Whereas if you've just got an Arduino, you use the Arduino language, kind of a C-level language, using the Arduino IDE on your PC, your laptop. And then there's Pi Serial, which you can use on the Raspberry Pi in Python to communicate with the Arduino, or with an actual Arduino, rather than just one of these add-on boards, and use that over USB. So this Python library, RPyGPIO, which is Ben's library, it's included in Raspbian, implemented in C, and you can configure a particular pin. So say pin 2, I'm going to use that as an input, or pin 3, I'm going to use as an output. You can read inputs, so say, is this one high or is it low, or is it, that might be, is the button pressed, or is the sensor going off? You can set outputs, so if you've got an LED attached to one of them, you can say turn it on or turn it off. There's a concept called wait for edge. So an edge is where a voltage changes. So if you press a button, you disrupt the voltage, and you can detect that a button has been pressed if that happens. And there's pin event detection. So you can set a callback to say, run this function when I receive an input on this pin. Or when I press the button, run this function, or do this bit of code. So this is a little circuit. So we've got going from 3 volts through a resistor and through an LED. So 3 volts is more than enough for an LED, so we use a resistor to limit that down to a nice voltage that the LED can cope with. And then it goes back into ground, so that's your 0 volts. That's a complete circuit. And so it's 3 volts going all the way through, so that LED is on. If we were to move it from 3 volts to GPIO 2, it's now user controllable. So you can write a Python program which, at some given moment, turns that pin 2 on, turns the LED on. So this is some code using the GPIO library. So import the library, set the mode up. So there's, a always more than one way of doing everything, of course, but there's 2 numbering systems for the pins, one kind of being numeric and the other being what the actual functions are. So that's what BCM means, the Broadcom pin layout. We're using LED on as number 2 because we're using pin 2. And we set that up as an output, like I said. Then while true, output true, and output false in a loop with sleeps that will flash the LED on and off every second. Another example, we've got a button wired up. Again, similar sort of circuit. We've got using pins, GPIO pin 17, wired round to ground, and we're using the Pi camera library. So set up pin 17 as an input, and this put up means pull up or down is set to up. So inputs are you either pull them up or pull them down, and then when the button is pressed, if you pull it up, the voltage will drop, and you detect that falling edge. Then the rest of the code, basically this is just a loop that will take a picture each time the button is pressed. So it gets to that line, wait for edge on that button, which is pin 17, wait for a falling edge on pin 17, and then continue, takes a picture with a enumerated number, and saves that in a folder. And this is a little resource that we made that's for creating a stop motion animation. We did this at the PyCon UK education track last year, which went down really well. Another little project, wiring up 2 different buttons to different pins, pins 2 and 3. And we add an event detection on each of those buttons. So given you do this in a loop, do this twice, so you'd set it up for pin number 2 and pin number 3. Tell it which function to run when it receives detects a falling edge on that pin. And the bounce time is how long you will allow between button presses. So that's 1,000 milliseconds a second. Then we've got a dictionary mapping a pin number to a particular sound. That's a Pygame sound object. And a function called play, which takes in the pin. So when the callback is called, it knows which pin called it, looks up the pin number in the sound pins dictionary, and plays that sound. So you've got a little music box, and you keep adding buttons, create different sounds, make a little kind of keyboard thing. So this is kind of a couple of cool little kits called the CamJam Edu kits. So CamJam is the Cambridge Raspberry Jam, the Raspberry Pi events that we have around the world. And they put together this little kit for simple projects like this. So you've got buttons, LEDs, resistors, and the second kit has a bunch of sensors in there. So you've got a motion sensor, a temperature sensor, and a light-dependent resistor, a light sensor. These are great for really reusable bits of components. The first kit is like £5, the second one is £7, and they're doing a new one. The kit 3 will be a robotics kit, so you'll be able to assemble these bits together and power the motors and assemble them to your Pi and drive the Pi around. So in the early days of Raspberry Pi, this is one of the first kind of add-on boards that was made available, the Gertboard. Gert was one of the original engineers behind the chip at Broadcom. He made the alpha board for the Raspberry Pi. And there's him teaching me to solder while I'm wearing an elf hat. Normal day at the office, as Carrie Ann said. And yeah, Gert created this thing, and it's this monstrosity that sits on top of your Pi, and he claims that this is the best thing ever, and it can do everything, and this will you can do all sorts of projects with this. It extends the possibilities of the Raspberry Pi. I mean, 2 things. You had to you bought it, and you had to solder it together, and you had to look at all those components and stuff, and there wasn't any software for it, so you had to kind of know exactly how the GPIO things work and be able to flip the bits and stuff and get it to do stuff. So then more and more people in the community started making their own add-on accessories and things. This is a little motor controller board. So you wire it up to 2 motors, and you're getting kind of extra voltage through the. There's a chip on there, and there's more power available through the battery pack. So you can power the motors. And this one there wasn't any software for it per se, but you could use the GPIO library to turn the pins on and off, and you could drive it around kind of that way. So it gave you a few examples, which were kind of enough to get going, and there wasn't really much more needed. And then later on, things like this started coming out. This is the Pibrella, which was an abstracted board which just had the traffic light set of LEDs, so red, yellow, or amber, and green, a button and a buzzer, and then some extra pins that you could use to connect motors and things to. But they actually provided a software package for this. So there's a little library in Python. You import the Pibrella, and pibrella.light.green.on will turn the green light on. And you can start to program in that kind of sensible way, where a child looking at this would know exactly what to do with some example code and how they could create a traffic light sequence with it. They even added things like button press events with this button.pressed, and you pass in the function, and that could flash your lights, all your lights on and off. This is an add-on board called Energenie. It's created by this company that make remote control switches, so you can switch off the Christmas lights with a remote control without having to get around the back. But they also made this add-on board that sits on top of the Pi, and they gave you a big thing of Python saying, yeah, just paste this in and you can run this, and it will turn off the pins arbitrarily. We had a young girl with us on work experience last year. She was 14, I think, and we said, could you take a look at this code and kind of work out what it's doing and kind of make it a bit more sensible and kind of condense it a bit. So we ended up with this. And I packaged it and uploaded it and took all the credit. And so now you can import Energenie and just use the switch on and switch off functions. So you can do, and that means you can drop it into your application like this. So this is a little Flask app. It has a little HTML thing that's just 2 giant buttons to switch it on and off from your phone. That's, getting started with IoT, if you like, resource. So what would it be? A year and a half or so ago when the B Plus came out, we created this. That's the original Raspberry Pi. Raspberry Pi 1, the first revision. And it had a 26 pins, 26-pin header. And the B Plus extended that to 40 pins. And that's what the Pi 2 looks like now. And we created this specification for add-on boards. So rather than kind of whatever shape or size it made sense, we said, you don't have to follow this, but it's a sensible specification for the size and and having these kind of gaps for the flex cables for the camera and display. I think this is the first talk I've given where the display exists. We have a little 7-inch touchscreen display that uses the ribbon cable at the end there, and it finally exists, so you can use that now. So yeah, we started another project we started doing around this time was looking at sous vide cooking, which is vacuum packing food like steak. You can do it with all sorts of food, and cooking it at a precise temperature. So we thought, well, if we can detect the temperature of the water, and we've got that thing that turns switches on and off. So we created an add-on board, which was obviously called the Chef Hat, one of our hats, and used an Energenie and just did some temperature moderation to determine whether the cooker should be on and off using Energenie. Really kind of novel hack you can buy these sous vide machines for, a couple of £100 or whatever, but nice to kind of build one yourself. We've got it's a bit of a work in progress. We put it to one side, but it's there's a library working on that. There's plenty of hats out there in the community, and there's a lot of businesses built around Raspberry Pi, not just selling the Raspberry Pi hardware itself, but all these accessories and add-ons. There's companies that are creating cool stuff, and it's great that we don't have to do all of this, and it means that we've got stuff to play with and great new ways of teaching, great new ways for people to learn. So this is one that's an 8x8 RGB pixel matrix that kind of fills up this whole space of our hat spec. This one is the Skywriter. You can kind of hover your hand over it and detect kind of how far away your hand is, or detect gestures with it. And then these ones are kind of prototyping boards that you can. These are actually little capacitive touch pads that you can you can press and run things when you press different sequences of those. And there's plenty more out there. There's all sorts of great add-on boards for every kind of need. We have a project called Astro Pi. We're sending 2 Raspberry Pis to the International Space Station at the end of this year. There's a British astronaut going up called Tim Peake. He's going to the ISS for 6 months, and as part of his mission, as well as the kind of scientific research, he's going to be doing some education programs. So there's, as well as this, he's going to be growing rocket seeds, and there's going to be things, people doing stuff in schools, comparing growing rocket seeds and, to ones that have been in space and that kind of thing. But Astro Pi is it's this thing. So it's a Raspberry Pi with a special sensor board, an LED board on top, in this magnificent flight case, which has been designed especially for this mission. A great aluminium case that contains the Pi and has all these great big shiny Apollo buttons on it. So 2 of these are going to be docked on these kind of bogan arms in the space station, running code written by kids in schools in the UK. There was a competition this year for kids to send in ideas of what they could do, and then later on to actually program their ideas and do something interesting with this sensor board. And we gave out a load of these to schools. To anyone who submitted an idea got sent a class set of these to code up their ideas and enter the competition. So it has an 8x8 full color LED matrix and sensors. There's temperature and humidity sensor, a pressure sensor, accelerometer, gyroscope, magnetometer, and it also has a mini joystick, so you can kind of make little games that use the sensors or use the LEDs. And there's going to be a lot of data logging and data collection up there. And they came up with some really, really crazy and imaginative ideas. And we're kind of working on creating some resources as well. And the ideas the kids are coming up with are way better than all of ours, of course. But And tomorrow is the Saturday of PyCon UK has been the education day, the day for kids. So we're having the kids in to do a Raspberry Jam, and we've got a load of these sense hats, so we're going to be doing some projects with them and trying out some of our resources. So this is going up to the space station in December. It'll be up longer than Tim Peake is staying up. He's going up for 6 months, and we're going to be leaving the Pis up there, and hopefully there'll be more potential for more people to get involved with that project and run some more experiments and more games and more interaction with the astronauts. So I've just kind of a last thing that I want to mention is so this is the standard GPIO library, and this is how you flash an LED. And I was thinking about this recently, about how this is a little for young children. This is kind of a little convoluted. There's a lot of steps there. It reminded me of the kind of Hello World program in Java, where there's lots of words that you kind of tell them to write, but explain, skip over explaining them. It doesn't matter what static void main args means. It doesn't matter what BCM means. It doesn't matter that you have to write GPIO twice and things like that. And there's nothing wrong with this. The library's great, and we've done some great projects with it. But I wanted to see if I could create something that like a kid-friendly version of this library. So like PyGame Zero, if you've heard of that, this is a Zero boilerplate PyGame module for education. I'm looking at creating this. It's a work in progress. So GPIO Zero, you have concepts of components rather than just looking at pin numbers. So you create an LED component, just tell it which pin it's attached to, and then you can turn it on with an on method. And any guesses how you turn it off? As another example, so bringing in an LED and button, creating a function that flashes an LED for a second, create an LED on pin 2, create a button on pin 3, and then something like, I haven't determined the API yet, but something like button.whenPressed and pass in. That's your add event detect, that's your callback. So when you press the button, it runs the hello. And I'm trying to find kind of novel ways of, it's a bit like the PyGame Zero is bringing Pygame, which is out here, to the 10% of it that you actually want to use when you're making a game. And this is kind of all the everyday stuff. So I'm looking at those cam jam kits and what's in there. So there's LEDs, there's buzzers, buttons, and a few basic sensors. And just kind of think, what do you want to do when you create one of these? What do you want to be able to do with it? And trying to keep it really simple so that people can extend on to using the full library. But just to get started, just making some really readable code that makes sense. If you're doing traffic lights and you want to learn about creating code for the traffic light sequence, it might not be about learning Python. It might not be about the code. It might be about the system and about computational thinking. So if you've got lots of long lines of code that you're telling the program how to do it, not what you want it to do. So this is kind of the reverse of that. So I'm going to be hacking on this on Monday. We have the sprints. We've got a few other projects that we're keen on supporting. So there's GPIO Zero with me, Pygame Zero with Dan. We've got this thing called Pi in the Sky, which is sending helium balloons up into the sky with Raspberry Pis and cameras attached. And there's a lot of software stack kind of required in the tracking and the GPS and stuff that's all written in C. And it's kind of, we're training some teachers on doing some of these launches so they can do their own and inspire the kids to be interested in this stuff. And we want them to be able to dive in and muck around with the code and do some cool stuff of their own. But it's we're going to need to look at porting some of that from C into Python. So if anyone wants to help with that, that'd be good. And there's also a project to create a decent version of Idle. Well, it's not even a version of Idle. It's a new IDE called Puppy, which Dan and Nick Tolliver are working on. So it'd be good if you want to join in any kind of education-focused projects. It'd be great to have you along. Thank you.
Time for about one question or two questions. I don't know. We're already on. See, man. Brilliant. Who's got a question? When's Raspbian Jessie coming out? Do you know? Or is that
Soon.
out of power? Soon.
Soon. It's always soon.
Over there. Luke, can you run that for that guy there?
So you've got Mathematica on there. There's an open source alternative to Mathematica called Sage. Who does one speak to or chat to about whether or not that could be released directly on there?
You could suggest it to me. I could suggest it to somebody else.
So have I now done that, or should we have a chat?
You heard it, right? Okay, so two of us have heard it.
So my job is done, or?
Okay, so post it on the forum so that you can get a response.
Yeah, great.
What's back on YouTube later?
Cool. Yeah.
Yeah, we're keen to put stuff in it that's going to be useful and going to get used, and without making the image too big to download. It's a real difficult balance. And obviously, Mathematica is bigger than a lot of stuff, but it's a partnership, and it's something that they've been very gracious in giving to us, and it's worth a lot proprietarily, if that's a word, to them. And it's a difficult choice, really. But.
Okay, thanks very much, Ben. Right. Sorry, we're out of time for questions. So.